Hi, this is Ellie from the Math Center. Today we're going to be talking about functions and their inverses. So to start out, we're going to go through a couple properties of inverse functions. Properties of inverse functions. The first thing that's important to note is that only one-to-one functions, one-to-one functions have inverses. So what is a one-to-one function? A one-to-one function is a function that passes both the vertical line test and the horizontal line test. So let me write that here for you. One-to-one function passes both vertical and horizontal line test. So we can see this by having a function such as a line. If we have function such as a line, we have our x-axis here, y-axis here, and we draw a line. This is our f of x. At every single point, you can draw a vertical line, and it will only hit the function at one point. Similarly, at every single point, we can draw a horizontal line, and it will only hit the function at one point. So it's a one-to-one function. An example of something that's not a one-to-one function would be something like a parabola. So if this is our f of x on our xy plane, then we can see that this horizontal line test does not pass. There are 2 points where this line hits the function, even though it does pass the vertical line test. So this is not a one-to-one function. Not one-to-one. Okay, another property of inverse functions that's important is that if f and g are inverses, well, let me rephrase that. F and g are inverses if and only if so f and g are inverses if and only if f of g of x equals x and g of f of x is equal to x. So if you were to take one of the functions and plug it into the other function, pretty much if you were to take the inverse and put it into the original function, you should get out x. You should always get the same thing that you put into it. So if you do something to a function and do the inverse, then you should get back the same value. A third property is that the inverse function, so the inverse of f, is mirrored over the line y equals x. This is a very graphical representation of an inverse function. And lastly, a very important property is that the domain of f is the range of g, and the range of f is the domain of g. So what this means is that the domain and the range switch for the function and its inverse. In order to illustrate all of these points, I'm going to use an example. So for the example, let's start out with a function such as y equals x plus 7 over 3 minus x. So let's first find the domain and range of this function over here. So the domain, everything that x can be, we know that the denominator cannot equal 0. So where does this denominator equal 0? If we set the denominator equal to 0, we find that x is going to be 3, therefore x cannot be 3. So our domain is going to go from negative infinity to 3, not including 3, union 3 to infinity. Now our range, in this case, is going to be the vertical asymptote. We can use the rule where we take the highest degree and the coefficients of the highest degree in order to find it. So we would get 1 over negative 1, or 1. So y cannot equal negative 1. So our range is going to be from negative infinity to negative 1, union negative 1 to infinity. So in order to find the inverse of y, we are going to switch x and y. So we get the function x equals y plus 7 over 3 minus y. Now what we're going to do is solve for y again in order to find the inverse. So we get x times 3 minus y equals y plus 7. All I did was multiply both sides by 3 minus y. Then I'm going to distribute this x in and get 3x minus xy is equal to y plus 7. Now since I'm solving for y, I'm going to group all of the x terms and everything else on the left and all of my y's on the right. So I'm going to get 3x minus 7 is equal to y plus xy. Then I'm going to factor out a y and get 3x minus 7 is equal to y times 1 plus x. And finally, I have y is equal to 3x minus 7 over 1 plus x. So this is my inverse. So my f inverse of x is equal to 3x minus 7 over 1 plus x. Let's examine the domain and range of this function. The domain of the inverse is everywhere with it is going to be found by setting the denominator equal to 0. So when the denominator is equal to 0 is at negative 1. So x cannot be negative 1. Or our domain is from negative infinity to negative 1, union negative 1 to infinity. Our range is our horizontal asymptote, or the coefficients of the highest degrees in the numerator and denominator. Here we see that it's 3 over 1, or 3, so y cannot be 3. And we see that our range is from negative infinity to 3, union 3 to infinity. Everything excluding 3. Now we can see that our domain is the same as our range of our initial function, and the range of our inverse is the same as the domain of the normal function. I hope this helps out with your inverse function finding.